Okay, hi there Year 12s. Shout out this time is going to Leighton. So good on you, Leighton. Let's go. Alright, we're looking at arc length this time. So what is arc length? Well, when we're looking at a circle, the whole circumference is the measurement around the outside from, if we go right around the circle. When we're talking about arc length, that's part of a circle's circumference. So say if this is a circle, then an arc would be any part of that circle. So say from here around to here, that might be an arc. Okay. Likewise, if we have just part of a circle, like a sort of a pizza slice, then this bit here, that's our arc. Okay. So that's what we're talking about when we're talking about an arc. So let's just say we have an arc like so, and we have an angle in there in degrees, and we want to know what the length of that is. So in order to do this, we need to think back to a circle for a second, and I'll just come over here. So with a circle, we have a formula for the circumference. The circumference is equal to 2 times pi times the radius, or another way of thinking about it is pi times diameter, but we're going to use this one for arc length. So when we're thinking about arc length, that I'll write L for arc length. It's going to be very similar. It's going to have that part 2 pi times r, but we just have to think about how this angle is going to affect it. So when we're looking at the angles the whole way around a circle, those are 360 degrees. And so if we're finding an arc length, we're finding just part of a circle's circumference. And so what we need to do is take whatever the angle is, divide it by 360, and then times by 2 pi r. So if we just tidy that up a little bit, we can write it as 2 times a over 360, and then times pi r. But then 2 and 360 can simplify down to 180 on the bottom, and so we can actually write this as a times pi times r all over 180, and that's a great formula for the arc length of a circle, and really easy to remember as well. You're just taking the angle, dividing it by 180, and then going pi times r. So even if you wanted to write it like this, you could write a over 180, angle over 180 times pi r, and that's pretty easy for you to remember. You may not be given that formula in that particular form on your formula sheet, so just be aware of that. Okay, so let's look at this example. Find the arc length of this segment. We're missing some pretty vital details here. So that angle there, I think, is supposed to be 125 degrees, and that radius is supposed to be 5 centimeters. So let's see how our formula works here. So we'll write it out. L equals arc length, angle over 180 times pi times r. So for this one, we're going to have 125 over 180 times pi times 5. This is where we get our calculator out, and we're going to have 125 divided by 180. Here we go, times pi times 5. Okay, so 10.91 is our answer. So 10.91 centimeters is our arc length for that question. So we've got a few questions down here. I've scribbled out a few of them because they use something called radians that we're not going to get into. So have a go at the ones that aren't scribbled out, and I'll put the answer for you.